Welcome back, everybody. Welcome back to the channel. So, today we're going to be talking about how to pre-process our first mutation. So, we're kind of back in the compiler now where we are basically ready to just continue on. But before we get into this, I know I made a video yesterday or Wednesday. I don't know why I always say that. I made a video on Wednesday talking about how to actually install the programming language. I made that video super late. I got like 4 hours of sleep, so I may have missed a few things. There's a couple things with the release that I didn't mention, and there's actually some stuff that I found out. So let's go through all of them. So the first thing is a bug. So for those of you who are programming in Linux, there is a known bug right now that has already been fixed. It will come in a later version where basically, if you guys remember, if I go to the runtime system and then the signal handler, if you have a Linux PC and you do a interrupt or a signal interrupt, basically you just type CTRL plus C, so Control C. You guys know what that is. If you type Control C, then basically you're going to end up triggering a signal interrupt. And for POSIX, I reset the console settings. Well, I wasn't necessarily doing this correctly. So I made a mistake with resetting the console settings. So if you did Control C, it would actually break the console. Now, there's nothing wrong with your computer. I just mess up the console settings every time because, yeah. Basically, I just use that for like reading and writing characters. So there is a workaround currently for that. The only workaround right now is if you read a character from the console. So you could either do read line, R-E-A, oops, why is it caps? R-E-A-D underscore line, or you could call read underscore char, and that will temporarily fix the problem. So you just have to call it one time, and then once you do that, then you should be fine. Linux should work, and you shouldn't, like, your console shouldn't be broken. Now let's talk about Windows. So I know that for the release 0.2.9, I have this release package. If you try to install this package here, and then you try to, first off, so there's a couple things, right? So once you install the package, you're going to get the package, and then basically you're going to need to extract all. Now, for some reason, Windows can't extract the zip file, which is kind of weird. So what you have to do is you have to install a program called 7-zip, and then basically just say extract to release package 2. 7-zip is a free program, so it's 7-zip or 7-zip org slash download HTML. I will put this as a link in the description below. But you could just download, whatever version you want. It's free. You don't have to like pay for anything, and then it should work just fine. Once you actually get it to open up into a package, I actually forgot to mention. So once you get the release and you have to install it, I mentioned the wrong folder that you're supposed to put all this stuff in. So if we navigate to the main page of the Sharp programming language, we can scroll down. There's a getting started. This information is also inside of the actual package that you download. It says create a folder C program files sharp bin. Originally, I thought that it was just C sharp bin, but I forgot that I switched it to program files at some point in the past. So that's the actual folder you want to create. So I've actually decided to delete Sharp, and I'm just going to go through the process. So if I go here, I'm going to actually install this on my computer. So if I try to run, so if I open up a git bash and try to run Sharp and then test.sharp, it's going to say Sharp command not found, or actually I should do Sharp C to actually test it. So if I do Sharp C, obviously it says it's not found. So I'm going to go here to the Windows C program files and create a new folder, and I'm going to call it Sharp. Once I do that, oops, make sure you name it correctly and not screw it up like I did. So the naming does matter. So it has to be, capital S HARP. Then you're going to want to create two new folders, a bin folder, and then another new folder, and include. INCLUE. Let's see. So now I'm going to go here to the support files. I'm going to copy this, go to include, paste that in, continue. Why? Okay. So it asked me to include every single file, whatever. That's fine. So now all the files are now included in the sharp include folder. Now I'm going to go over to the bin folder. I'm going to go back out to the release bin, and I'm going to go to 64 Windows sharp C sharp exe. Now, one thing I will mention about this that's very important is that, like, when it comes to Linux and Windows, these executables are based off of the x86 platform. So if you're running Windows and you have an ARM computer, it's not going to work. So check your PC. So you can actually do that by typing system information, and you can check here for the system type. Now, if your system type says x64 base PC or x32 base PC for 32, well, I don't have a 32-bit for Windows. So basically, the system type has to say x64 base PC. If it's not running that family of processor, then it won't work because that's what this is built on. I don't have direct access to ARM computers, so it's kind of difficult for me to build all these things and all these executable files when I don't have access to that. Just make sure you have this as your CPU. So once I have, this in the bin, now I'm going to need to go up here to environment variables. I'm going to need to go to environment variables and make sure it's this one, guys. I know there's a couple path variables. Make sure that it's this one specifically for the system path. You should have a bunch of stuff already in there. Once I select the path, then I'm going to make sure that I include the C program files sharp bin folder in the actual path variable. Once you click OK, you click OK, say OK, and then if I do git bash, and then I try to run the command again, it's actually going to take some time to run the command. And I didn't get any errors saying that it couldn't find the include files or anything like that because they're in the correct folder. And then if I say sharp and then out, I should get hello world. So that's a full end-to-end video on how to install it on Windows. Sorry I didn't do a good enough job on my previous. So let me know if you guys have any other issues. Again, the console thing is only a Linux issue, and the workaround, remember, is to just read a character from the console. That's going to be the best way of doing it. That way your console doesn't get destroyed. Now, if you do hit Control C while the program's running, all you'll have to do is just click the X on the console, close out of it. You can use a task manager to shut down Sharp if it's still running, even though it shouldn't be. And then you can just open up a new console and then rerun it again. But that's a huge pain in the butt. Now that we're done with that, now that's out the way, let's actually get into the actual programming language today. So we're kind of now back at the compiler. So let me close all these files. So I'm going to go up to the runtime system, go to the backend compiler, and now for compile, like I said, you are going to want to create this post-process function. Now this is going to return a Boolean because what we want to do is we want to try to pre-process and post-process the entire programming language. And this post-process is going to be doing a crap ton of work to make sure that the user actually did things correctly in the programming language. So once we get done executing all these functions, majority of the compiler should be finished. So you want to set your processing stage equal to post-processing because now we're at that stage. And then after that, there's compiling, obviously, but we're here. So once you set your post-processing or your processing stage, then you want to set the unstable classes. Now, this is kind of a weird thing, right? So I have this concept of unprocessed classes. Now, it's been a minute since we've gone over everything, but you guys remember if I go back to pre-process, there's a potential that we could create classes during the pre-processing stage when we are resolving base classes. Because when we resolve a superclass, we basically have to try to find the class that's representative of the base class that each class is inheriting. So if I go into resolve base class, we actually compile a reference pointer. And if you guys remember, compile reference pointer has the potential to compile a generic class reference. Now, I know we haven't gone over compiling a generic class reference because that's a whole nother can of worms that we're just not ready to do. It's going to be dependent upon a lot of crap in the compiler to actually be ready for us to do. So that's still why I haven't gone over it yet. But basically, that's why I have this unprocessed classes list. So This is going to be a list of unprocessed classes that we can't compile everything all at once, basically. So if I go back, basically, we want to get the unstable classes. And these classes inside this list are considered unstable. So before we get into it, I'm going to show you guys why it's unstable. So if I go to preprocess, and then I go to resolve base class, resolve superclass, resolve base class, compile reference pointer, and then compile generic class reference. Basically, when we come down to here, it's actually time to create the class. So we're literally gonna I'm gonna go over this code later, but we're gonna create the class. But the problem is, in order to process this class, so obviously we're gonna set up the name and everything like that for the generic class. But in order to do any of this crap, we have to have a processing stage of greater than or equal to post-processing. So that means that the class, as far as we're concerned, has, no fields, no methods, nothing. So it literally is just an empty class, which means it's unprocessed and unstable. So what I do is normally classes who are in the post-processing stage execute this source code. So we need to bring the source code up to speed based on the various things that we need to do here. Now, why do I have stuff segmented? Because in the compiler, you're going to be doing a lot of things that you're touching lots of points in the compiler. And you're basically going to be expecting certain pieces of data to be present during the compilation. So for instance, if I'm trying to compile something, I'm going to expect that all the types for every single function have already been resolved. You can't compile something until after the fact of when everything is resolved. And it's not just about your class. You got to realize that you're working with potentially hundreds of thousands of pieces of data sets that you're working with. So it's not just about your class, but it's also about understanding that in order to compile your class, every single other class also has to be post-processed as well. So you have to break this up into stages because it's just not going to work. So yeah, that's why I do that. So that's kind of why we have that unprocessed classes or unstable classes field. And what you want to do with that is you want to just store it for now and then call preprocess mutations. So that's what we're going to be going over today. So if you remember, a mutation is a change on an actual class that we have. So if I create a class called test, and in the test, it has an ID field of, I don't know, whatever, right? And then let's say this is, created in some file in some library, unit test lib.sharp, right? Somewhere off in some other file somewhere else. Now let's say in my file, in my, main.sharp file, let's say I want to modify this test class because I want to add more functionality. So I can say mutate test, and then I can then add in their name. Like, so if I wanted to add the name of the unit test or whatever, then I can do that and just add, basically operate on this as if I was actually creating the class. So for pre-processing mutations, if you guys remember, I know it's been a while, but I basically have the same setup that I always do everywhere else. So let's go over it for the first time, and then every subsequent video, it'll just be the same stuff. So you want to go for the total amount of parsers. You want to get the current parser at the index. You want to update the error management instance. We've already gone over this function. You basically just either, if the error management instance is null, we create it with the parameters passed in by the C options flags. And if we go back, so once you do that, then you want to get the total amount of current errors that we have in the system. So you want to get the unfiltered errors because you want to make sure that there was any new errors generated after this, then we want to know about it. So we get the current total errors, and then we add a new scope. So we're going to add a global scope, which is going to represent the SRT global class. So it's going to be the underscore SRT underscore global as the head class of every single class. Now the actual class pointer is going to be figured out at the first index. So you want to go for the total amount of ASTs inside the current parser. Then you want to get each branch out, and then you want to check to see if x is equal to 0. If you guys remember, We do that because at the top of every single sharp file, we are required to specify the module before we do anything else. So we check to see if the first item is a AST module declaration. If so, we parse the module by getting the module by parsing the module declaration. We've already gone over this function, but it's a very simple one. It literally just for loops through an entire AST and just appends a string basically, and then it just returns that string. So it's pretty simple. And then we want to get that module from the code obfuscation system, and we create a mock package by passing in the name and the GUID, and then we try to get the index of that, and then we do that. Now the module should already be created because we would have already gone over that when we pre-processed the programming language, so that's what we're calling get module instead of create module. After that, we find the class of the global class, which is going to be the SRT global. That's a field that I created at the top of the file. We pass it the current module, and we pass it the classes list to search for the class in that classes list. That's going to give us the SRT global as our top level class. Now, if the first module is not, or if the first AST is not a module declaration, we're going to set the current module to undefined module. If you guys remember, undefined module is literally just going to be a module called undefined. So that's pretty much it. And this was populated and created at the start of the actual compilation function. So we just created that and passed that in from the code obfuscation system. Then once we do that, we're good to go, and we just for loop through the branches we need. Now, since we're at a point to where we've pretty much already pre-processed the entire programming language, we're literally only going to just care about the cases that we care about. So we have AST class declaration, generic class, and mutate declarations. So to speed things up, let's just go over mutate declarations. So what you want to do is for pre-processing a mutate declaration, you basically want to check to see, you want to pass in the current class, right? So, and the AST. So obviously we need the branch or the AST that the mutex or the mutate is on. Once we do that, then we check to see if the current class is null. If so, then we create a reference pointer. We compile a reference pointer based on the name that's in there. So we're going to say compile reference pointer of AST name and AST reference pointer. So you're basically just passing in name of the thing that you're trying to mutate. So it's going to be whatever the class is, and we pass it the current class because you could also be mutating classes inside of generic classes as well, and that's a whole nother can of worms. We'll get into that later. But once you compile the reference pointer, you're going to get the current class by resolving the class reference by passing in the actual address or the AST that it was defined at the pointer and true. Now we're literally calling into the same function that we did when we tried to basically compile a base class, and all this function is trying to do is literally just trying to resolve a class inside of the programming language. So if you guys want to check that out, then you can search for the video. I'll put a link in the description below. You can look at the video where I talked about how to basically parse base classes in the programming language. So once we do that, then we basically say the current class, then after that, we basically check to see if the current class is not equal to null. If so, then we check to see if the current class has a stable flag. Now, if you guys remember, you can set the stable flag to classes, which basically does not allow you to mutate. So just want to make sure you do that. And yeah, so if the class is stable, then we say cannot mutate stable class. We pass it the full name of the current class. After that, we check to see if the class is a generic. We do that by getting the type of the class and checking to see if that is a generic. You guys remember, we've already kind of gone over this. Each class has a type, and the type holds several different values. We can have either a normal class, interface, generic, or enum. Now, you could have an enum generic, or you can have a generic interface, or you could have just a simple normal class. So those are the various different types. We also want to check to see if the generic owner is equal to null. What that means is that this is the true original generic owner class. So basically in our programming language, as we're creating generics, we're going to have two types of classes. So let's say this test class was in fact a generic class. Well, if I go back here, when we actually create the class, we're going to create a test generic, which is going to be like the base model of every class. So that way, if I go ahead and create a test of type var, I can model this class off of this base generic class or the generic owner because this is owned by this class, right? So this class is the original owner, and then these are like its childs. So then if I create another one of like, I don't know, test of object, again, I can model this class off of the original owner of the generic class. So that's kind of the concept behind it. We'll see that later on as the programming language progresses. But basically, you want to say current class get mutations, and then you want to add if. So what you're going to do is you're just going to want to get a reference to the class mutations. It's literally just an AST, and the reason why I do ASTs is because literally once we're ready to actually process this class mutation, we can literally just come back into here and process this AST as if we were compiling it for the first time in the compiler. So it's a really powerful system that I use. But yeah, you just want to make sure you create this getter function for that actual field. Once you do that, then you're good to go. Now notice, it's a generic class, so I'm not immediately processing any information inside of here because you don't want to do that. You want to wait. Basically, when it comes to generics, you want to wait as long as humanly possible to process the generic class. And the concept that I have in my programming language is the compiler is very lazy. So the compiler, when it comes to figuring things out, tries to wait the maximum amount of time to figure out any information because the longer it waits, the higher chance that it has that that data is going to be there and the higher chance that you're not going to have to bounce around and do some weird magic than I have in the programming language to try to figure out all these types and stuff. So the idea is you want to just wait. So we do that so that way later on when we're ready, we can process all the mutations inside of each generic class. Otherwise though, if it's not a generic class, we want to pre-process a class declaration and you want to pass whether or not it's an interface and the current class. And what this is going to do is this is basically exactly what we were doing when we first compiled it. So if you guys remember, I'm actually going to just put a space there. So if we go back to the original compile function, when we pre-process, when it comes time to actually pre-process a class declaration, we're calling the exact same function that we called when we actually pre-process the class for the first time. So we're literally just recalling back into the same function to perform the same tasks. Now what that means is if you have a name field in here already called string or whatever, it doesn't matter the type, then you're going to get a collision and you're going to get an error saying that this field was already defined. But that doesn't matter. So for simplicity's sake, we literally just do that to make our lives easier with the compiler. And then after that, we resolve the superclass, which again, we've already created this function where we pass in the current class that we're processing and the AST. Now, it's only going to resolve this superclass if we have a superclass, right? So obviously here, I'm not setting a superclass. But if I said I wanted test to now inherit this class as a base, so I could say, you know, some class, right? If I wanted to inherit some class as a base, then now there's an AST ready to process here for resolve base class. But yeah, so that's kind of how that works. And again, it's just another function that we've already created, so we just call it the same thing. And once we're done with that, that's pretty much it. Processing mutations isn't that complicated. Now let's actually look to see how to process class mutations and then how to process generic class mutations. So for processing class mutations, you want to create a function called preprocess class declaration for mutation. And in there, it's going to be very simple, guys. Literally, we just create a block, right? And that's going to be the AST that we're going to have. And literally, we're not doing all this fancy stuff, right? So normally when we're processing a class, we're like setting the scope and doing all this other stuff. We don't care about any of that because we're not going to use that information anyway. So we literally just for loop through the entire AST of the class. We get each branch. We check for compiler errors, which just make sure that we haven't blown over our limit. And if I go back, so what you want to do is if you get another class declaration, you're literally just going to call back into this function recursively. If you get a generic class declaration, you're going to, again, call back into this function recursively. And if we get a mutate declaration inside of the actual class, then that's when we call this function that we just went over. So literally, if you have, I don't know, some class, and you're creating this class and then you're mutating test, well, as we're kind of compiling this, we don't care about the information here because we've already processed it. We just want to care about the mutations, and that's it. So once we do that, then we're kind of good. So once we go back out of here, let's look to see. So when it comes to processing generic classes, again, we call back into the same function. And that's pretty much it. Now, what this allows us to do is, so if we have a mutation inside of a generic class, so I know this is kind of silly. You can do this though. This is technically legal. So if I create a class of T, and then I mutate T inside of here, so if I go here, mutate test. So I know this is kind of silly, but let's say I, have this class of test, and then I mutate test inside of test or whatever, right? Then I'm going to have to provide the exact type of the class. So I can't say, test of T and mutate test of T, right? Or this is probably a bad example. Let's say I have some other class, right? I can't create a some other class dynamically by passing in the type here. It has to be the exact type already created because that's just how mutations work. Otherwise, it creates a whole host of other issues in my compiler that are just not fun to deal with. So keep that in mind. Mutations are not going to be dynamic. We're going to have to actually put the type of the physical class inside of the mutation. So after that, let's see. So if I go back to compile and we go to post-process, pre-process class mutations, now we're done. So now we've pre-processed classes for mutations. And for generic classes, again, at the high level of pre-processed class mutations, you call the same function. And we've already gone over this one. And finally, after you do all that, obviously you want to check for compiler errors to make sure you haven't blown over your limit. And if there are any new errors found, we've already gone over this. This just checks the unfiltered error count and subtracts that from the total errors and see if it's greater than 0, meaning that we've had new errors since we recorded our last errors here. Then if we have any new errors, we add this current parser to the failed parsers, which represents a failed file. And then we just say remove scope. So we just want to remove the scope that we created up here, and that's it. So that's how you basically process mutations in a programming language. It's pretty easy. I would have thought it would have been a lot harder, but actually turns out you can just reuse all the same code that we just created. So that's going to be it for today, guys. Hope you guys enjoyed the video. As usual, if you have any questions, definitely put them in the comment section below. And I know I've made a couple of videos talking about the programming language, installing it and stuff. So hopefully I explained everything better in this video. Thanks for sticking around and really trying to install the programming language. I really appreciate it, guys, for your dedication as well. That's really awesome. So yeah, and of course, if you guys would love to help support the channel, as usual, you can always head over to the GitHub repository, androidevcd/sharp, and when you do, definitely watch, start, and fork this repository. That's going to give this language a lot more visibility and let other developers know this language exists. Also, now that I'm kind of at a different place in the programming language, I feel a little bit more comfortable saying this. But if you guys are looking to help out the channel in more ways than just following and subscribing, you don't just have to do the extremely hard stuff. If you want, you can leave that up to me. That's totally fine. You can always do whatever is comfortable for you. But if you want, I have a standard library, right? A support library that I'm creating. Now, obviously, I wrote all this stuff myself. It's a very small API, but it is really starting to grow and get a lot bigger. If you guys wanted to help out with the development of the programming language, it would be a massive, massive help if you helped me out building the standard library. So it doesn't have to be complicated stuff, right? Like you don't have to do all this IO stuff. Like recently, I just created, so if I go to remastered, I just added something to the actual API that'll be in the next version, which is a concept of channels. And a channel is basically a way for you to talk between threads. So if you want to send data from one thread to another, you can send that data directly to that thread, and that thread can listen for that data, and you can send whatever you want. You can send streams of data, so this could be used for like audio processing, reading a file from one thread and passing that data to another thread to process that file. There's a whole host of applications for this. But yeah, so you don't have to do all this complex, crazy stuff. If you want, you can just stay a little bit more simple and do stuff like creating a list class, which I already have. So like, for example, I don't have a linked list class or anything like that. Or you could just create simple functions that do various different things, like, printing stuff to the console or whatever. So that would, like I said, be a huge help. Also, if you're curious about some of the stuff that I'm looking to add in the future to the language or stuff that I'm working on currently, you can head over to the roadmap section And in there's going to be a pretty decent description of what's going on with the programming language, and you can kind of see in real time kind of what I've been up to with the actual language development. So that's going to be it for today, guys. Of course, if you're new to the channel, definitely consider subscribing, and until next time, I'll see you guys later.